Imagine being a developer, tasked with creating a robot that could potentially save lives in disaster-stricken areas. Sounds exciting, right? But what are the challenges faced in this endeavor? To start with, rescue robots are often deployed in environments where GPS signals are degraded or entirely absent. This means the robots need to possess autonomous navigation capabilities. They must be able to plot their own course, make decisions independently, and adapt to rapidly changing conditions. This is no mean feat. Moreover, the unpredictable nature of disaster environments adds another layer of complexity. Conditions can change in a heartbeat, and the robots need to be able to respond accordingly. This requires advanced programming, cutting-edge hardware, and a level of adaptability that is difficult to achieve. So it's clear that building rescue robots is no easy task. But what about the technology that enables them to navigate these tricky terrains? The key to autonomous navigation in GPS-degraded environments lies in a technique known as VSLAM, or Visual Simultaneous Localization and Mapping. This technique is heavily reliant on a variety of sensors. LiDAR, radar, and stereo cameras are the central components in this sensor array. LiDAR, or light detection and ranging, uses laser light to measure distances and create detailed maps of the environment. It's incredibly accurate, but can struggle in foggy or dusty scenarios. Radar, on the other hand, uses radio waves, making it more resilient to adverse weather conditions, but it lacks the detailed resolution that LiDAR provides. Then we have the stereo cameras, which work much like our own eyes, capturing three-dimensional images to determine depth and distance. However, they require good lighting conditions to perform optimally. Each sensor has its strengths and weaknesses, but together, they enable robots to map and navigate their surroundings. While these sensors are pivotal in guiding these robots, there are still ethical concerns that need addressing. As with any technology that could potentially save lives, there are ethical considerations to be taken into account. Let's delve into some of the ethical conundrums surrounding rescue robots. First up, accountability. If a rescue robot fails to save a life, who should shoulder the blame? Is it the developers, the operators, or the robot itself? This is a gray area that needs careful thought. Next, we have decision-making in life-threatening situations. Robots, unlike humans, lack the emotional intelligence to make decisions based on empathy. So, can we trust a machine to make the right call when a life is hanging in the balance? Lastly, the potential for misuse. As with any tool, rescue robots can be misused for nefarious purposes. This opens up a Pandora's box of ethical dilemmas. While the technology is advancing rapidly, these ethical implications to ensure that rescue robots truly serve their purpose, to save lives.